like most papers you read are not clear. It takes like a lot to kind of like really work through and dissect the paper. And it takes a lot of like active effort to understand what's going on in your average econ paper versus you can't expect to have someone put in that much active effort to your writing in a business sense. It's more like you get like 5 minutes max of someone's time and you need to be able to convey like your information very, very clearly. And so one thing I like have my people on my team do is I say like, okay, I'm gonna like read the first few lines of whatever you write. I'm gonna stop there. Here's what I got from this. Is that what you wanted me to get?
Welcome. It's great to have you. Do you want to start by introducing yourself?
Yeah, absolutely. Thanks for having me on. So my name is Vincent Martin. I support the economics team within Meta's Central Applied Science organization. We're a central team, which typically means that we partner with various teams across the business, bringing what I like to call like good economics to those spaces. Broadly, what that kind of means is like good applications of economic theory. And yeah, really excited to be here and happy to chat a little bit more about what the team does and kind of the state of tech economists.
Yeah, so why don't we dive into that, what your team does specifically, and then in the conversation we can situate it in the broader tech economics landscape.
Yeah, that sounds great. So my team is in a little bit of a unique position relative to, I think, economists at most tech companies. So most tech companies don't have economist job titles, the exception, or the big exception that I'm aware of, at least being Amazon, where they have like a well-defined job family for economists. In most cases, economists kind of tend to fit into UX research or like more traditional data science type roles. The role on my team is we're actually more a hybrid between economists and engineers. So, I mean, if you go into like the weeds of our job family classification, I'm technically a software engineering manager. The people on my team are software engineering specialists, which is like a similar job family to like machine learning engineers, for instance. And this is a little bit different from kind of the traditional DS roles. In the traditional DS roles for economists, for instance, I think there's a lot of emphasis that's placed on measurement. So like, how do I run better single one-off like A/B tests? How do I use observational causal inference in particular settings? Or like, how do I just apply like generally the economist toolkit for more like business policy oriented decisions? My team's role is more on the building things side. So we have like several tracks that we focus on. And kind of the unifying theme is that we're trying to like build systems that leverage kind of like economic ways of thinking at scale.
Is that unique to Meta or is that unique to your team specifically at Meta?
So it's not unique to my team specifically at Meta. So in the broader like Central Applied Science org that my team is a part of, we have other teams that are full of operations researchers, statisticians, like other disciplines that kind of operate in the same way. I have not seen this degree of like economists kind of focusing on building things while still remaining within their core skill set at other companies. I think in some cases, economists have entered like machine learning engineer job families. In those cases, I think they're more operating as traditional machine learning engineers, even though they have an econ background, versus my team is specifically engineering from an economics perspective.
Right. That does sound pretty unique because talking to colleagues in tech economics broadly, right? Some it sounds like they're doing an extension of a postdoc almost, right? It's more researchy. And then, as you said, some do engineering, but then it's not economics.
Yeah, exactly. And there's like this one example where I was at a friend's house and like chatting about what my team does to someone who like who's not an economist, and they were a little surprised. They said like, "Oh, I would have thought like economists were kind of a cost center," which makes sense if you think about economists in this kind of like business strategy, like finance role. Like we want to measure the business, but we're not directly contributing to the bottom line, except maybe through kind of like better decision making in some like abstract sense. Versus my team is like far more downstream in the causal chain of how the company makes revenue. So we're like we build systems, we A/B test those systems against what the company is currently doing, and then we demonstrate, hey, we're actually driving incremental revenue for the company with the systems that we're designing. As far as I know, that's not like a dynamic that happens at a lot of tech companies with economists.
And so in theory, it sounds like you could have an economist that does more the typical policy-oriented analysis partner with an engineering team to implement the things you're doing. But the benefit of having an economist who also knows how to do engineering is that there's no kind of loss of information in the transfer of knowledge, right, from the application to the implementation.
Yeah, so I did mention we're a central team, and so we don't, there is actually a big exception here, but in most cases we don't own the systems that we're operating on. So we partner with like machine learning engineers on product teams. And what we try to do is we embed the economists who are working with them with that team. And a lot of the like system design elements, for instance, like how should you think about like data collection to power these systems, are designed by the economists on my team. And then like the final implementation like into the production code base is typically more heavily done by our machine learning engineering partners with like kind of a little bit more hands-on work from the people on my team.
So do you want to go into some of the more specific models that your team develops? Is it forecasting, causal inference? Like what kind of stuff do you do?
Yeah, so I think our team is more or less structured on kind of like the Amazon differentiation between like economist skill sets. So they have like kind of 3 tracks. One is for like time series, reduced form causal analysis, and I think industrial organization. So we don't do any industrial organization. So the 3 tracks on my team are forecasting, which has a pretty one-to-one mapping with like kind of the time series background, or even like macroeconomists. I have some of the only macroeconomists at Meta on my team. The second one is instead of reduced form causal analysis, we do causal ML, right? And so this is like kind of building online causal inference systems in order to feed into decisions that are made by machine learning models, as opposed to these kind of like policy guiding reduced form analyses. And then the third one is we also build causal inference tooling. So the idea is that we're building things that data scientists can leverage when they need to implement either experiments in a more like complicated way if they're dealing with kind of complicated dynamics there, or in settings where experimentation is not feasible. And we're not focusing on kind of the one-off analysis. We're focusing on like how can we actually get these approaches to scale. That one's actually a little tricky because I think a lot of observational causal inference doesn't scale in the way that we would want it to, in the sense that what I've seen when people talk about observational causal inference platforms is they basically want a machine that spits out the causal estimate for whatever arbitrary situation you're coming up with. And I'm pretty strongly opposed to that. Like observational causal inference, a lot of it kind of comes down to like, do you have plausible exogeneity? Do you have a natural experiment? Or do you have some kind of variation you can exploit specific to the situation? And there are like different strategies you take depending on the situation. But it doesn't really scale in the same way that experimentation does, right? In an experimentation platform, you have exogeneity built in because you have randomization from your platform. And so on average, if you're just naively running experiments, you're going to get the right answer most of the time, versus on average, if you're just naively using observational causal inference techniques without any kind of like domain knowledge or understanding of the variation in your data, you're going to get the wrong answer most of the time. And so a lot of what we focus on when we talk about observational causal inference tooling are things like, how can we build like robustness frameworks? How can we build tooling that enables data scientists to falsify what they're saying? Because it's very easy to come up with a stat-sig result that's causal, but it's not really causal, right?
Yeah, it certainly sounds dangerous to give people who don't understand all the caveats of observational causal inference the framework, right? Or the tools to get a result. And that was my follow-up question. As much as you maybe can't automate the production of the estimate, maybe you can automate, I guess, all the prompts that someone who is building it should consider, right? Have you thought about this? And if you think RDD applies, then how do you think about, you know, your exogeneity in this particular type of situation and approach?
Yeah, exactly. And it's kind of like there's prompting in terms of like alerts, and more generally, like if you're doing something that's leveraging variation over time, you should be able to, like, placebo testing is a well understood method for robustness and method for falsification. And so like that's the area where you can really provide more advanced tooling. And it's like, hey, you think you have a causal result with this particular types of data, you could imagine running that through a system and then it's spitting out like, yeah, this seems okay. Or at least I'm not able to falsify with placebo testing, for instance, versus no, your placebo testing is also coming up with the results that look like they're causal, and there's probably something much deeper going on in this analysis.
And so do you think this kind of tooling can be used by people who are not PhD economists or equivalently trained scientists? Like, could that be used by someone who has an undergrad in data science?
That's the idea. And in particular, like at Meta, we care very deeply about like getting kind of the right answers, so that we're using like valid data for making decisions as opposed to just like kind of one-off averages. But at the same time, it's like very difficult to kind of implement kind of the Amazon style where you hire 500 economists. And like that's one way you could do this. Like I'm just going to hire a bunch of PhD economists to do every single analysis. I don't think that's a great model for anyone. I don't think it's fun if you're a PhD in economics and you're just doing like product data science work day in, day out, and not really like kind of honing your skills or staying with the state of the art. And so I don't think like PhD economists want to just be doing these like one-off analyses on an ongoing basis. I think that's more for like the undergrad or master's level data scientists who want to kind of get into the product data. And then on the flip side, like you do need some level of expertise to actually tackle these problems well. And that's like kind of what I was saying in terms of my team is trying to build these tools to scale those techniques.
Yeah, no, I think that makes sense, right? Because as a PhD economist or similar level of scientist, at some point you see a problem and you kind of know the steps you have to go through, but then it can be a little bit tedious or boring if you just have to do that over and over and over again. You could be more of a consultant to someone more junior who has this kind of tooling that you're building.
I was just going to add, like, also, like, these problems don't come up every day. So even if you are an economist working in a product data science role and you do get like an interesting, like, observational causal inference problem to solve one day, you could then go months without encountering another problem like that, and then you're just kind of building dashboards or doing other stuff that is far less interesting that like you really didn't need to go to a PhD to do.
Yeah, well, and that stuff at some point might also be more and more automated, potentially by AI tools and so on.
Potentially. Yet to see that, but potentially.
Potentially, yeah, I see the kind of smile on your face. So we'll get into the AI stuff in a little bit. I want to circle back to the forecasting you mentioned. So does your team do, what do you think about when you say econometrics and forecasting, like ARIMA models, or do you use more of machine learning type models? And of course, there's a lot of hype today around different kinds of forecasting models.
Yeah, absolutely. So the approaches we use are fairly state of the art, and we have like a very clearly defined objective there, which is accuracy, both in like a backtest sense and like we should be delivering accurate forecasts on an ongoing basis. So like we can benchmark how well did our forecast actually do against like some kind of like realized impact or realized outcome. So generally, like we actually don't leverage a lot of the standard econometrics time series techniques that I learned in graduate school for forecasting. Like there's like a little bit of ARIMA there, but the current state of the art and like the M competition is actually like a great place for this. Basically a competition where forecasters from different disciplines get together and they try out different methodologies on like novel data sets and they just see what actually works. And so past M competitions have kind of like shown like, hey, ML techniques don't do as well as statistical models. That's been changing, and ML techniques are starting to do like better than baseline statistical models as they're getting more sophisticated. But the current state of the art is basically ensemble approaches. So you use like a variety of model, like 40 or 50 different approaches, and then you figure out how to weight those approaches in an efficient manner. And the nice thing about that is like you can pick up on things like regime changes or these other like changes in dynamics that actually economists are really good about thinking of, but more naturally in your model than saying like, hey, I have like one model and then I'm going to apply it everywhere.
And so it sounds like a criticism of some of these more black box models might be precisely that they're black box and that there isn't as much explainability. But by understanding the properties of these different models that you ensemble, and then you understand the weights you're applying, right? And you just said the economists are good at reasoning about things like regime changes. You can kind of add a layer of understanding and explainability to your forecast, even if some of the models are inherently more black box. Would that be a fair characterization?
I think that's right. It's not something that we focus on as much because, like I said, like we're okay with black box accuracy at the current stage we are in, like kind of the research and product applications. I think the trick I've found with explainability is that if you ask 3 different people what explainability means, you'll get 4 different answers. So for instance, some people say like explainability is just being able to like talk about the trends, like trends are explainable. That's true, but I don't think that's actually explainable in the sense that an economist might think about it. Like economists would think about explainability in terms of decomposing your forecast into underlying drivers, and then you could potentially go a step further, which is like how do those drivers causally impact your forecast? And so this is something that my team does think a little bit about, but in terms of like delivering explainability to customers, it's a little bit difficult because everyone has their own sense of what that means. And so we've mostly focused on accuracy in our forecasting efforts.
Okay. And I guess what can happen often, right, is the forecast deteriorates and the customer asks why, right? And that's where whatever you call explainability comes in.
Yeah, exactly. And this is where it also kind of goes into the eye of the beholder. So like a very typical way to approach these kind of like, hey, forecast deteriorated, we missed. Why did we miss? Is you do these finance, they call them bridging exercises, which is where you try to say like, here are the components and drivers of the forecast that we got wrong. Here's each of their contributions to the overall forecast miss. There's a little bit of like structural storytelling there. And that kind of works if you have like a good structural model for the way the world works. In fact, in some sense, you need a structural model. And that's a little bit deviated from the work that my team has done so far, where we're purely in kind of statistical and ML land. But we do have like an active work stream on our team to kind of say like, how do we actually marry like a statistical ML forecast that is far more accurate and the structural model where like I have an explicit sense of what are the drivers that should drive a particular forecast.
So if you were to assign a percentage to the importance of feature engineering versus the model choice and the ensembling itself, what would you say?
Oh, that's a good question. I don't know if I could always give you a sense of how much feature engineering is more important than the modeling itself. And the reason I say that is because it really depends on what your data is and have you nailed down kind of the true drivers, right? If you have like a good sense of the causal drivers for like whatever you're trying to forecast, and you know that these are the causal drivers, but you don't exactly know how they feed into the forecast or how they like kind of play into the forecast. There, I think feature engineering is probably more important than modeling because it's more a matter of like, how do I actually get the information that I know is there out of the data that I have, versus if you're trying to throw everything into like, if I don't have a good structural understanding of how things work and I want to just kind of like go ahead with accuracy, then you're probably better off on the modeling side.
Yeah, no, that makes sense. So going back a little bit to the economics profession, what do you think it is that distinguishes an economist from a machine learning engineer or some other related scientific discipline, right? Because you keep mentioning economists, you clearly hire economists. Like why is that?
So I think the big advantage that economists have goes back to this kind of phrase, good economics, which is a phrase that like Phil Leslie, a VP at Amazon in the economist job family there, used to say. What that kind of means is like good application of economic theory. I think that's something that economists tend to excel at, like really understanding, here's how I turn a business problem, I want to say into a math problem, but that's kind of like a lazy shorthand for this because it's not really like explicitly a math problem. But here's how I think about like the core underlying drivers of this business problem. And here's how I turn this into a problem I can tackle and reason about with modeling. So economists are really, really good at that. Where economists, at least like where I really struggle with hiring economists, and in full transparency, my entire team is not economists. I support the econ team, but it's about 50-50 between economists and statisticians. And part of the reason for that is just it's very difficult to find economists with enough of this computer science skills to kind of operate at the level that we need to be operating as a team. So for instance, like a lot of like in labor econ, for instance, there's less exposure to kind of like the cutting edge of even what machine learning techniques are, like coding in Python, like these kind of things. It's not like, hey, I need you to really like code bubble sort or any of these like kind of crazy, it's not that crazy, but like I don't need you to like really deeply know like how to optimally implement computer science algorithms. But we are looking for people who like have enough understanding of these that they can speak to kind of CS algorithms and have a general sense of how to apply them, but also just like are more well versed on the machine learning side, which my take is like it's very, very difficult to hire those people. And the people we do end up hiring tend to be very entrepreneurial in the sense that they go outside the core curriculum of their departments and learn the ML and learn the Python and kind of learn the technology that they need to know to be successful in tech.
Is this lack of skills an issue equally for fresh grads as well as for people with maybe a couple of years of experience?
I think it's both, frankly. I think for fresh grads, it's a bigger problem. I think for fresh grads, the frustration is that people don't seem to be getting exposure to these are the types of skills that you really need. The problem when you try to engage with like placement directors at departments is that they have no idea what skills are needed in tech. And so like it's very difficult to identify like who are the graduates who are most well suited for tech. Like I'll ask placement coordinators at like kind of top schools, like, hey, who are your people who are most inclined to tech? And I'll get back a bunch of CVs with people who don't even list Python, for instance, or like there's no ML, like there's no indication from the CV that they have any aptitude for a tech role. So that's like kind of one thing. And then on the like industry hiring side, it's also a little bit of an issue. I don't know if it's an issue because my role is also just very different from other roles in the sense that we talked about, like it's a little bit less on just kind of the data science side, a little bit more on the engineering side. And so economists coming from industry who have been on the data science side and either haven't been interested in or just haven't been exposed to kind of like the more machine learning algorithms and like system design questions aren't as strong of a fit. And I try to emphasize this when I do like intro calls for my team and like, look, we have a coding portion. This is kind of like the core job expectation. You should really think about this and think about if this is what you want to do versus the like multitude of other jobs that economists can do in tech.
Could you list some of the specific skills where you see economists fail? Because you mentioned coding skills, and that's a very broad range of things, right? Of what a coding skill can mean.
Yeah, so the way that we try to evaluate coding is through like these leak code style problems, which is like, hey, you have like this really abstract kind of problem, and we want you to write an algorithm in code to actually solve that problem. And it's not what most economists are trained to do. Like, quite frankly, I wasn't trained to do it. Like, I had to learn to do this separately. And it also isn't really reflective of what you do on the job in the sense that, like, you're not coding like a 2-pointers solution in your day-to-day job. But what it is actually telling us is, like, can this person kind of reason through, like, the CS style problems you would have in your job? So, for instance, like, hey, I want to create like a pipeline to get this data into a particular shape, and then I want to like leverage this model, and maybe there are a lot of like inefficiencies along the way, and if you just like brute force that, it's going to be a really expensive pipeline, or it's not going to work, it's going to break a lot. And like if you can reason through the like leak code style problem, you probably can also reason through, hey, here's how I need to think about setting up my data structures or setting up like these other elements of kind of like coding a system or system design to be successful. And that's really like what we're looking for there.
Yeah, and I can totally see why that's something economists are not trained to do, right? Because it's a different kind of computation that your brain needs to do, right? Like you almost need to kind of visualize the data in your mind and how it's all going to efficiently flow and merge, right? And then implement that, which is different from carefully thinking about the exogeneity of something when you estimate a model.
Yeah, exactly. And you need both. And this is like the tricky thing about hiring for this like hybrid engineer economist role, that you need to be able to think through, here are all the ways that data is going to lie to me in the system and it's not going to work. And then also think through, here is like the technical complexity, and I need to deliver a solution that addresses both like the exogeneity piece and also the implementation complexity.
And the interesting thing is that if you can have both, I would imagine there is positive spillovers between the two skills, right? Because sometimes you work with data engineers who are good at the data pipeline part, but they have zero imagination about the kinds of economic problems the data could have, and vice versa.
Yeah, exactly. Or even like structuring systems. So for instance, one of the things that my team does actually on the causal ML side, which I didn't get as much chance to talk to yet, but like we talked earlier about kind of like how important exogeneity is for getting the right answer. And then like one of the things my team does is we build systems that try to optimize not for just like outcomes, but for incremental outcomes. So like the causal effect of doing something. And we want to be able to make decisions that are going to like causally drive the business in the right direction. In particular, it's not like we're presenting this analysis to some exec who's then going to make some decision. We want a machine learning algorithm to be making these kinds of decisions at scale, like thousands of times per day. And the idea is each time it makes this decision, it's driving the business metric in the right direction. And one of the trade-offs there is like one way you could think about doing that is I have always on experimentation, where I like constantly have randomization, and my constant randomization is where I get my causal estimates, and I feed those causal estimates back into my optimization system. And that's really expensive. In particular, like collecting that random data is like, it's really expensive. Like A/B tests in general are like can be really expensive. But then when you talk about like always on experimentation and something that potentially also like customers could abuse, there's all kinds of like really tricky dynamics to navigate there. And so can you just do this offline? Can you just do this with observational causal inference instead of always on experimentation? And then like under what circumstances can you actually do that? And like there are the systems set up in such a way that you could do just like a regression discontinuity, for instance, and you get the same answer as the always online experimentation for basically none of the cost. And you need that econ background to kind of think through that element. But then you also need to be able to think through the system design elements that I talked about as well.
So the thing that is interesting in this, right, is that obviously there's a selection bias into disciplines that people who choose computer science or engineering have in mind that on average probably works differently and is more suited towards thinking about these kinds of algorithmic problems, whereas economists, and maybe especially economists who specialize in experiments or field experiments, have this more kind of detail-oriented chess player kind of operation of the brain. And obviously you want to have both. And how much is it, I guess, training issue, right? Like if you're an economist who has this high aptitude for this economist type of thinking, but say you're listening to this podcast and you want to apply for this role, can you train yourself? And to what degree can you train yourself? And what should you be doing, right? Suppose someone actually wants to apply an interview for your team.
Yeah, I mean, I think, first of all, you absolutely can teach yourself this stuff. Like if you're getting a PhD in economics, you're probably pretty smart to begin with. And I think a lot of these things are just kind of like mental blocks where it's like, hey, I haven't done this in the past. I don't know if I can do this now. And my answer is like, you absolutely can. Like other people who have gone through PhDs in economics and have not gotten coursework in this kind of stuff have been able to pick it up, myself included. I never took a computer science course in my life. I pretty much learned everything that I need to know for this either on the job or like adjacent to on the job. And I would say, like, again, the people who are successful at this are fairly entrepreneurial in the sense that they reach out and engage with people in the industry to begin with and try to learn about like, hey, here is how to efficiently learn the types of things that I need to learn. A little sad that they have to do that. I almost would wish that academic departments would have a little bit more engagement with industry so that they could like kind of highlight here's the path for those types of students. But I mean, for now, absent that, the best way is to engage with things like this podcast, engage with like the tech econ group within LinkedIn, for instance, and just kind of learn here is what's out there and here's how I kind of navigate that world.
Yeah. And I totally agree. I think it's unfortunate that there seems to be such a huge gap between the econ departments and the private sector, right? And especially because these tools would be really useful even if you do academic research, right? Being able to set up a performance database and a pipeline that does something useful. I guess on the flip side, right, because you need to be entrepreneurial to learn these things as an economist today, you are getting a select pool of people who are able to pass your exams, right? Who not only have the technical capacity, but also have this entrepreneurial mindset, which I think must be very useful on the job itself.
That's true. There is like some selection there. I don't think the entrepreneurial element is everything though. There's like also elements of productivity, for instance. And I'll give you an explicit example. Like when I started out early in my career in tech, I kind of thought like, hey, the academic research or the papers that you write in graduate school are completely useless for this. And I've actually changed my view on this since I started hiring. And I think I have a much more nuanced view on this now, which is The topic of the research can matter a little bit, but actually like being able to get research out there in like 5 or 6 years that you're in graduate school is actually a signal of productivity that also matters. And what I mean by that is like if you have someone who's interested in tech, but they have no papers or they have like half a paper after 5 or 6 years of graduate school, that's not a great sign that they're going to be able to operate at the pace that tech operates, where you have like these 6 months performance cycles and you have to like demonstrate impact on like a fairly like tight cadence. And so like, yes, there's the entrepreneurship in terms of like, I'm just going to get out there and ask questions and learn what I need to do. But there's also kind of like some baseline element of productivity that's also very important for tech.
Yeah, no, definitely. And I know some people who chose to stay in academia who are maybe 5-6 years in now and have a list of papers longer than you can scroll through in a reasonable time, right? And that's this productivity that would apply in different areas as well. And so you said about 50% of your team are economists. Who is the other 50% of the team?
Typically PhDs in statistics. We also hire a little bit in like biostats. So these are generally like people who have backgrounds in also causal inference and time series forecasting. So yeah, I mean like these are like somewhat similar. I think that what's missing there relative to economists is economists get more training in kind of like theorizing about problems. And so like we talked about like kind of the good economics like way of thinking about problems and mapping those problems into solutions. That's something that the economists tend to be a little bit better at. On the stats side, a lot of times they actually have kind of more state-of-the-art statistical methods for addressing particular problems. And so, for instance, we have a lot of folks who are kind of like more sophisticated in the way they think about like Bayesian statistics and applying those to business problems. Like I mentioned that a lot of the time series work that my team does not actually come from the econometrics literature. It comes from like kind of more external forecasting engagements. And so the statisticians who hire have a lot more exposure to those kind of venues. So the combination of like the skill sets has worked out really, really well for us. But it also does kind of point to like, if you're an economist and you have a really good understanding of economic theory and you're productive and you're willing to kind of go into like kind of like learn more of these computer science type skills, like these are the areas where you can also like, if you're looking for another dimension to tech up, like you can think about that as well.
So if I were to characterize like an avatar of an economist who would be suitable for this type of role, I imagine someone who knows what production quality code looks like, is highly skilled in, say, Python, PySpark, right? Knows how to use command line to a good degree, right? Has some idea of what performant versus terribly unperformant code looks like, right? Is of course not an expert in all the aspects of writing super highly performant code, but like does understand the basics of it, and of course knows econometrics and statistics.
I think that's right. That might actually be a little bit even on the exceptional side for computer science skills, in the sense that like, you know, what we're looking for is someone who like can pick up this kind of stuff fairly quickly and can demonstrate that they can pick up this stuff very quickly and talk about it in an intelligent way. So like, can you write like an algorithm in Python to solve a problem and then talk about like the time and memory complexity of that? And that's something like realistically, if you're a graduate student, you could just sit down for a month and learn that kind of stuff. Maybe a couple months if you need to also pick up the Python and other stuff. But assuming you already know Python and you just want to kind of like learn the basic algorithm structure, I mean, it's no more difficult than going through like first year courses.
Yeah, no, definitely. I think you just need to be interested in it and do the work, right? I guess it's like with most things. And I actually think it's really, really interesting, right? And because in the end, it's once you put something in production, right? Like it's very real. Either it takes 30 seconds to run or it takes 2 minutes, right? It either costs X amount of dollars or 10X amount of dollars. So these are very tangible things once you put them in production.
And I would actually say like what appeals to me a lot is the tangibility on the impact side. So like there's one form of impact which is like I do this analysis goes to this executive who then makes a different decision, and then that changes the bottom line of the company. And it's a little hard to measure that last step there, but that's also different than saying like, hey, I have this methodology, I put this methodology into production, we test it against the alternative, and we make 100, 200 million more dollars using this approach. And that's like very visceral, real quantitative impact that I think my team is one of the like few places in the tech econ world where you can really do that.
Yeah, yeah. And so one thing we haven't talked about is communication skills. And this is kind of a recurrent topic when I talk to people who hire PhD scientists, that sometimes we are terrible at communication, right? And if you want to make an impact and talk to executives who presumably don't have a PhD in economics, you need to be able to communicate what you're doing and why and what the impact is. Is that a hurdle when you hire economists, or not as much as the technical skills?
It's definitely a hurdle. And like, this is like something that economists struggle with a lot. I remember one of the first like director level reviews I had when I was starting out in Economist at Amazon, maybe a couple months in, and like the director took maybe a 3-minute look at what I had written up, and his first comment was, "This is terribly written. I don't understand what you're saying at all." Because I was trying to write it like I thought you should write things, like a paper, and like being a little bit verbose and being very like it was not clear what I was trying to get out, and there was very little clarity of thought. And I've since gotten a lot better with that, and that has definitely been a major factor in progressing my career. I don't know if this is a hurdle in terms of getting the job. Certainly it's a hurdle in terms of like, if you're able to communicate well in your interviews, that demonstrates your technical knowledge very well. What I generally find with new grads out of their PhD, though, is that I need to expect that for 6 to 12 months, they need a lot of hand-holding in terms of how to write for a business audience. And it's not just the execs, by the way. A lot of the times my team works with like machine learning engineers, and explaining to a machine learning engineer why you need double ML or some kind of like debiasing, as opposed to like, let's just run a random forest or, you know, train a neural net on the outcome data directly, is really hard. And it's a different type of, but it's a different type of writing, but it's like the same idea that you want to just have like extreme clarity in what you write and extreme clarity in your thinking. And I just expect that I'm going to have to take a lot of time, or the senior folks on my team are going to have to take a lot of time to like coach new grads and how to do that.
Yeah. So you use the phrase clarity in thinking, which I think is the key here, right? Because you can't have clear writing without having a clarity of thought. And I think that doesn't get emphasized enough in education. I mean, undergraduate education, I won't even mention it. I think undergrads can't write, period, most of them, right? I think PhDs are better, but it's not something that gets emphasized in our training, really.
No, not at all. I mean, if you think about even like writing a paper, like writing a paper, like most papers you read are not clear. It takes like a lot to kind of like really work through and dissect the paper. And it takes a lot of like active effort to understand what's going on in your average econ paper, versus you can't expect to have someone put in that much active effort to your writing in a business sense. It's more like you get like 5 minutes max of someone's time, and you need to be able to convey like your information very, very clearly. And so one thing I like have my people on my team do is I say like, okay, I'm going to like read the first few lines of whatever you write. I'm going to stop there. Here's what I got from this. Is that what you wanted me to get? And it really forces people to think about like, what is the key point I want to convey? And then how do I convey that key point as efficiently as possible?
I think that's one of the really rewarding parts of working in tech as an economist, that you're forced to learn all of these skills, right? Which are, I think, just useful in life. So sometimes I think PhDs are hesitant to go into tech because they say, oh, is my research freedom going to be constrained? And it's like, it's actually going to be constrained by reality, because what you're doing needs to have a real impact, right? It can't be this theoretical thing that you publish, then you get citations and you get tenure, so you can publish more things that get more citations, right? And like, I don't want to kind of bash academic research, right? There's a lot of really important and interesting stuff that gets done that we use in tech. But you have this reality type constraint. Is this making someone money or saving money or something like that?
Yeah, exactly. I do think you have a little bit of that reality constraint in academia as well, because there's some constraint on what like the zeitgeist of academia is interested in a given moment. Like, it has to be kind of a topic that reviewers and editors will find sufficiently interesting to publish a paper, and like there are ways you can kind of think about going through that. But I agree, like the feedback loop in tech and industry in particular is much faster and shorter. And so like you really need to be on top of like, what's the so what of whatever I'm writing or whatever I'm doing.
For an economist who has the toolkit of all of the traditional causal inference type things that we use, synthetic controls and RDD and so on, how much should they be investing in, say, understanding what transformers do, training deep learning models, and so on?
Yeah, that's a good question. So I would say it's more important to have like strong foundations for ML than it is at this point for understanding like the mechanics specifically of transformers. And this kind of gets into like the AI conversation where, for instance, like there's a lot of, I'll circle back to the forecasting stuff that my team does because we've kind of looked at this a little bit and we're planning on doing more evaluations here. But if you look at a lot of like transformer based forecasting, and the idea here is that you tokenize kind of like different time series, and you have like, suppose I have millions and millions of time series, then I can uncover patterns where like if I see this snippet of a time series, then the next most likely time series is this other snippet, which I've seen in my training data, and like I can use that approach to kind of like forecast. They don't do very well right now. Like the promise is basically like I can know nothing about forecasting. I put my data into this machine, and in a zero shot sense, I'll get a good forecast or a good enough forecast, and it's very costless to use. That's at least the promise. The reality is that, I mean, if you look at like kind of a lot of the evaluation, they do much worse, like 10% or worse, less accurate than kind of like ensemble statistical methods or other state-of-the-art methods. And a lot of these papers, kind of the thing that you see is they benchmark the transformer methods against other transformer methods, and then they ignore all the other evaluations, like even more naive ones, like even ARIMA, and like that's kind of a red flag when someone's not assessing their approach against these kind of methods. So I'm open-minded to the idea that like these things could be valuable, and I think it's important to understand how they work and how they could work and like what their trade-offs and limitations are. They're not at the point where I would say this is like what you should focus on if you're trying to get a job in tech, in the sense of like really going into deeply into the mechanics of how they work and like how to use them.
Yeah. And I'm curious, you personally, since it is such a quickly evolving space, and I imagine you have to be on top of things that aren't only strictly causal inference, how do you keep up with it? Do you read papers from computer science? Do you, I don't know, look at Twitter or X or what's conferences?
Like personally, I listen to a lot of podcasts and just kind of like read tech news. Like Stratechery, for instance, is like a pretty popular one. It's on the less technical side. It's like kind of more the business and product sense. But they do come up with like, hey, here are the like models and approaches that are really making a splash on the product side. And usually like from there, I'll kind of backtrack into like, okay, what are they actually doing here? Like how does something like GPT work at a very high level? That's typically like how I kind of keep track of things. There's a lot of hype though. And so I think if you try to dive into like every paper, like first of all, the publishing cycles in computer science are very, very fast, much faster than economics, right? So you'll like put out a paper in 3 months and then put out another paper 3 months later that says the last paper didn't work, or it was like retracting that last paper because it's now no longer state of the art. So like reading all the computer science papers and holding down a full-time job is not really possible. So I wouldn't really start there. It's also like high noise to signal, I think. And so like figuring out here's where these things seem to be influencing the business direction of companies, and then backing into like, okay, how do these things work? And then where is that going? And is that going into a place where I see a clear enough line of sight that this is going to be something that I really need to tech up on?
And so thinking about forecasting, right, you can think about, I guess, a range of depth of thought you have when you make the model, right? Where on one end you could take data and you could throw it into some auto ML pipeline that runs over a range of hyperparameters and spits out forecasts, and then you get a forecast with some accuracy. And then on the other end of the spectrum, you could have a causal identification of drivers of the thing we're forecasting and have some kind of causally valid estimate that powers the forecast. And then I guess we can have a range of things in between. So how important is it to think about causality when you run forecasts, where the causality could even come in not only in the variable selection, but even thinking about structural breaks, right? Like that's causal aspect of it.
So I think this comes down to like how sophisticated is the organization about forecasting. And there's like a very wide spectrum that I've seen, even within Meta, for instance, right? So you can start like, I think a lot of organizations kind of start with like simple Excel-based approach, and they look at things like year-over-year growth and just kind of project that out into the future, right? What ends up happening is that they tend to evolve into more structural models where we start to think more deeply about like, okay, what's actually driving this forecast? So you could think about like advertising in Meta, and it's like, oh, if I want to forecast how much like advertising revenue, for instance, one thing I may be useful is like how many people are using Facebook or Instagram. And so then you start to think about like, okay, what are these drivers, these other series that might be underlying kind of like the core thing that I want to forecast? And you start thinking about like structural models there. And that's when you start thinking about like, okay, at least in a causal graph type of sense, what's going into this metric. And then you kind of start thinking about, okay, like I have a decent sense of how the business works and how things are operating. Now I want to get more accurate. How do I get more accurate? And this is where like you kind of get into the more sophisticated statistical modeling, and you start thinking about like ML and different approaches. And that's where like my team is partly operating in terms of like, how do you get the accuracy from ML without completely going black box and avoiding kind of like, hey, I understand these structural parameters and I understand like the structural causation with these drivers. And so the North Star that I think for forecasting on my team is like, can we get a strong statistical understanding of how drivers affect that forecast and also get the accuracy? And some of that is like, you're not going to just get that with modeling. Some of that is like, hey, I know in the future there's going to be this special holiday that we've never seen before, and it's going to be similar to Black Friday, and I know it's going to be on like, I don't know, September 1st, for example. How do I put that in my forecast? Right? No ML model or no statistical model is going to pick that up. So there's like domain knowledge and judgmental overrides, and how do you incorporate that information into your forecast as well? And that gets back to kind of this question of like causal inference, because it's like, hey, I know there are certain elements that are going to influence my forecast, that are going to cause changes in my forecast. So I want the accuracy from ML, from historical patterns, and I also want the not heuristic, but like human intelligence also built in my forecast. And I don't think anyone has like a great systematic way of combining those yet.
Yeah, well, and that's where I think the economists, right? Because we can lean on economic modeling to help inform those seemingly manual adjustments.
Yeah, exactly. And even like things that, I mean, this is one of the areas where the Economist Toolkit comes in. Like even thinking about things is like, how do I residualize out certain elements of my forecast and then treat like these other kind of things as like, how do those affect the residuals? Is like a really structured way of thinking about how do I think about augmenting a forecast with like kind of this more structural understanding of what's going on.
Does your team use DAGs and do calculus in any of your modeling, or do you use the more, I guess, traditional potential outcome framework that economists use? And I realize there's, of course, a huge overlap between those two.
Yeah, it's a good question. I think in general, like on the causal ML side, a lot of this is potential outcomes. It's a little tricky because like they're kind of more philosophical frameworks about thinking about these things rather than like explicit tools. I mean, like when you're thinking about like ML modeling, I think it's more explicitly like the Rubin causal framework, because there it's kind of like, hey, we want to flip this switch or like pull this lever, and like what's the causal outcome of that, and like it's very easy to kind of reason about that in the potential outcomes framework. For forecasting, like I would say we think about it in terms of DAGs, particularly when we were talking about like drivers, and like this kind of goes into like operationally, this goes into how we think about what to include in our forecast and what to prioritize including. Because we actually do own a forecasting system on my team. And so like adding in new data and new features takes a bunch of effort for us. And so we try to say like, how do I want to prioritize onboarding new data? And it's hard to evaluate before you onboard that data, like whether or not something is going to be useful. And so like DAGs are like a great way of doing that. Like, can we tell a story to ourselves for why one particular piece of data or one particular metric would be more useful for tightening the residual and reducing error than another one?
Yeah, no, DAGs are very visually satisfying, and they can also get very complicated to draw pretty quickly if you have a bunch of stuff in them.
Yeah, exactly.
And so I guess DAGs obviously come from computer science, and there's a lot of interesting developments in computer science right now with AI, and some people claim it can do causal things, and some people claim it can't. And there's, of course, a lot of tools with varying degrees of usefulness that are coming out. How do you see the whole AI space impacting economists' work?
I think a lot of people tend to say like either this is like this is a massive game changer, or this is like absolutely nothing. And I think I'm probably somewhere in the middle. I'm very much wait and see on how like AI will actually affect economists' work. I think there's like some element of people saying like, hey, this will actually just replace economists, and like this could actually do like causal inference. I haven't actually seen any evidence of that yet, and I've seen a lot of hype around this, and it's a little tricky kind of cutting through the hype and actually realizing like, hey, this is something with staying power that is like going to be useful on an ongoing basis. I do think that there is a lot of room for seeing here is some product applicate. Like if I got this technology to be really, really good, here are some ways you could use this. But I think what we're finding is like out of the gate, there were a lot of answers for if I had the perfect system, here is what we could use it for. And we just seem to be like nowhere close to there yet. And so like I'm very much wait and see. Like I think the technology will continue to evolve and things will get better. If I had to like kind of forecast this, I would not say in the next couple of years that we're going to be replacing economists with just like your econ GPT.
I'm in the same camp. I do think for coding, right? These tools are useful, not always. They do speed up part of coding, but then you kind of have to know how to ask it, and sometimes it gives you stupid things back. Now, there seems to be a pretty quick rate of improvement in terms of how well they can do these things. So I do see it replacing, to some extent, more junior data engineers and data scientists, right? Like if I can ask ChatGPT to code something for me, and I don't have to spend time kind of explaining my reasoning to a human, that could be more effective in situations.
It can be. The way that I've seen this used on my team for coding, I've had like kind of mixed feedback about like coding improvements. So back in the day, and by that I mean like 3 years ago, if you probably didn't memorize the entire pandas library, for instance, right? And so certain things that you do all the time, you just have at the tip of your fingers, but a lot of the time, like I did this a lot, I would like go back to the documentation and look up. I had like a general idea of how to do it. I go back to the documentation and just look up the function I need, or like a combination of functions, like try to piece together, here's how I would do what I needed to do. And in theory now, you can use GPT and you actually just get like a faster answer to that. And what I've found is you do get a faster answer. It's not always necessarily the right answer. And so I've had like stories, people on my team who like argue with their GPTs about like, this is not actually a sequel that gets me what I want. I actually need this other thing. And then it says, I'm sorry. And then it does something else. And then it's also wrong. And there's like this big back and forth. So assuming that's like accurate, I think it does improve your efficiency. I'm still not convinced it actually replaces like the junior engineer or junior DE, because it does seem like you still need to have like a substantial amount of knowledge to actually understand if something is right or not.
Yeah, no, that's true. And I guess maybe I should backtrack on that a little bit. If you're working somewhere where the economists are expected to know how to code, the GPT is going to enhance the productivity of said economist, right? And then if you work somewhere where the economist doesn't know how to code, then they still need to collaborate with an engineer. So you're probably right here, right? And then the engineer is going to be more productive because of the AI coding tools.
Yeah, exactly. And it's like it's a productivity booster. So maybe like at an organizational level, you need 2 economists instead of 3 economists, or like you need a fewer engineers potentially. But actually, like historical examples like of productivity gains, like power tools or like the cotton gin or any of these other things, like they didn't really replace the labor market entirely. Things shifted around. So I think there are shifts around that will happen. I do think there are productivity gains to be had. It's still definitely in its infancy.
No, it's definitely interesting times though.
Yes, absolutely.
Yeah. Is there anything I haven't asked you about that you would like to mention?
We covered kind of like a lot of the stuff, causality and forecasting. We talked about the economist skill gap. I think these are kind of like the main topics, unless there's like some last minute topic that you think would be like really interesting for economists.
Yeah, no, I think this was super interesting, and I'm personally a huge proponent of coding and economists knowing how to code. I find coding very enjoyable. So I'm glad to hear that there are companies out there that have such clear requirements for good coding for economists. So hopefully this is inspiring to people who want to level up their coding, and we'll put some links to resources and so on below.
Yeah, absolutely.
Perfect. Well, thank you so much for coming on.
Thank you for having me. It was a real pleasure.